Till now we have seen many problems about Mealy machine and Murray machine. Now the question you should ask me is, which one is more powerful? So if I have to say that one is powerful than the other, one should be able to solve some problems which the other will not be able to solve. Let us say we have seen two kinds of finite automata with inputs. See, finite automata with inputs, with outputs, we have seen two types. One is Murray machine and other is Mealy machine, right? And we have constructed for many problems both of them. Now the obvious question is, which one is powerful than the other? If I have to say that Murray is powerful than the Mealy, then Murray should be able to solve some problems which Mealy will not be able to solve. Or if I have to say that Mealy is powerful than Murray, then it should be able to solve some problems which this machine will not be able to solve. But both are actually equivalent in power. If I have to show that both are equivalent on power, then I'll take a Murray machine, if I can convert it to Mealy, and if I can take any Mealy machine and if I can convert it to Murray, then we can say that both are equivalent. So in this question, let's take an example of Murray machine and convert it to Mealy. So let us say I want to count number of A's using a Murray machine. So, or I want to print out number of A's mod 3. Then the Murray machine is going to look like this. We have three states. We'll have three states: Q0, Q0, Q1 and Q2. So let us assume that we are counting only A's. So on A's we are counting, and on B's we will not count. So on B's we will not count. Okay. So what is the remainder in Q0? Remainder in Q0 is 0. See, this is nothing but the some DFA which accepts set of all strings in which number of A's is divisible by 3 or congruent 1 mod 3 or congruent 2 mod 3. So, and this is the Murray machine which will print out the remainder of number of A's when divided by 3. So let us say this is 1 and this is 2. Fine. So this is the Murray machine, some Murray machine. Don't worry about what it is doing. This is some Murray machine. Now I want to convert it to Mealy machine. So what is the main difference between Murray and Mealy? In Mealy machine, the output has to be associated with the transitions rather than the states. In Murray machine, output is associated with states. So I have to move the output onto the transitions. So understand this. I am going to explain this in two ways. One is by transition diagram, other is by transition table. First, let us try to understand it in terms of transition diagram, state transition diagram. It will be very easy. Just see this. Now, see this transition. This transition is going from Q0 and is going to Q0. So wherever it is leading to, just go to that state and see the output associated. Since the output associated is 0, I am going to write it on the transition. Since this edge is going to Q0 and the transition and the output associated with Q0 is 0, therefore I am going to write it as Q0. Now check this edge. This edge is going to Q1 and the output associated with Q1 is 1, therefore I will write 1. Now see this. Edge is going to Q1 and the output associated with Q1 is 1, therefore I am going to write Q1. Now see this. This is going to Q2 and the output associated with Q2 is 2, therefore I am going to write it as 2. And this is going to Q2, output associated with 2. And this is coming to Q0 and output associated is 0. So this is the Mealy machine. So you can simply remove this, and this is the Mealy machine. Now the output is associated with transitions rather than states. So how did I convert it? I have first finished the diagram for Murray machine, and then I have taken each transition, and if a transition is going to some state, I'll take the output associated with that state and I'm associating with the transition. Now let us say let us take the state transition table for the same Mealy machine. Now Mealy machine state transition table is like this. Q0 is the start state, Q1 and Q2, and inputs are A and B. So Q0 on A is going to Q1 and Q0 on B is going to Q0 itself, and Q1 on B A is going to Q2 and B is going to Q1 itself, and it is going to Q0 and it is going to Q2 itself. So this is the state transition diagram for state transition table for Mealy machine. Now what is the output? Output associated with Q0 is 0, output associated with Q1 is 1, output associated with Q2 is 2. So in order to convert this table into Mealy table, first construct the table and then see this. What is the state it is going to? It is going to the state Q1. Now go to Q1 and see what is the output associated. Therefore we get 1, which means Q0 on small a will go to Q1 and output as 1. Okay. Now again see this. This is going to Q0. What is the output associated with Q0? It is nothing but 0. Therefore you write 0, which means Q0 on B will go to Q0 and output 0. Q0 on B will go to Q0 and output 0. Now look at this. It is going to Q2, therefore go to state Q2 and whatever is the output associated with Q2, write it there. Which means Q1 on A is going to Q2 and outputting 2. Q1 on A is going to Q2 and outputting 2. Now check this one. Q1, so go to state Q1 and what is the input? Output associated 1, therefore write it as 1. Which means Q1 on B is going to Q1 and output 1. Which means Q1 on B is going to Q1 and output is 1. Next one, check this. What about Q0? Q0 output associated with Q0 is 0. Therefore Q2 on A is going to Q0 and output is 0. Q2 on A is going to Q0 and output is 0. Now see this, Q2. Fine. So Q2, what is the output associated with Q2? It is 2. Therefore I am writing it as 2. Which means Q2 on B is going to Q2 and the output is 0. Output is 2. Q2 on B is going to Q2 and the output is 2. So how did I construct this? Initially I have constructed the state transition table for Mealy machine, given Mealy machine, and then in the transitions in the delta function, this is obviously delta function, right? In the delta function I am associating the output whatever is associated with this state. If Q1 is associated with Q1, Q1 is associated with 1, therefore I am going to take 1 and I am going to write it here. You can remove this. So this is the final Mealy machine. So we shall even see more examples. Fine.